Okay, so this is a quick hinge video on shifts of log functions. If you weren't able to guess the horizontal and vertical shifts, we're just going to go over how you will find the horizontal and vertical shifts of log functions in this video, so please take notes. So first, let's identify where the horizontal and vertical shift comes from. So you're familiar with on your tests, you have to circle the horizontal shift and box the vertical. So let's go ahead and do that for this log function. So the horizontal shift is going to come from the argument, and the vertical shift will come from this part right here. So this is my vertical shift, and this is where my horizontal shift comes from. So in order to find the horizontal shift, it's going to be very similar to our exponential functions. We're going to set this whole thing equal to 0. So we will set the argument equal to 0 and solve for x. So if I set this one equal to 0, I get x minus 3 equals 0. I add 3 on both sides, and I get x equals 3. So my shift would then be to the right 3. And so it's the same as your exponential functions again. If you have a positive when you solve for x, then it's going to shift to the right. If you have a negative, it's going to shift to the left. And that's if for whatever x is. So x is a positive 3 here, that means it shifts to the right 3. So really quick, let's look at a graph of this. So this is the common log graph, and my shift right now is 0. So this is the original point, and when h is 1, we would set this exponent equal to 0, and we would find that x minus 1, when we set it equal to 0, well, only a positive 1 for x would give us 0, because 1 minus 1 is 0. And so it shifts to the right one because x is going to be equal to 1. Now, if I shift to the left, I find that my h is going to be negative, and so I have a minus sign here that would give me a minus. A negative would give me a positive 8. And so if h was 8, if h was a positive 8, well, the only thing that's going to give me 0 for my argument is going to be a negative 8. So when x is negative 8, my graph shifted to the left 8. The vertical shift is a little more straightforward. So we have to know where to locate the vertical shift. So again, I'm just going to box where we found the vertical shift for our log functions. So this vertical shift would be up 5. And again, similar to our exponential functions, if we have a plus for our vertical shift, it means it's going to shift upwards. If we have a minus sign, that means our function will shift downwards. So here I have my little slider acting as my vertical shift. Right now there is no vertical shift on our graph, but if I shift the slider to 1, what do you think the graph's going to do? Well, if I shift the slider to 1, my graph moved up 1. So the shift was up 1. However, if I move the slider down, my v becomes, so say my slider is now, v is negative 4. This would look like minus 4. And so my graph has shifted down 4. So let's go ahead and work through these examples. So the first thing I'm going to do is identify the shifts. This is the horizontal shift. This is the vertical shift. If I want to find my horizontal shift, I'm going to set x plus 3, which is the argument of the log, equal to 0. solve for x, so I subtract 3 from both sides, and I'm left with x equals negative 3. So for our horizontal shifts, I know that negative means left, so my shift will be to the left 3. My vertical shift, straightforward, it's boxed. That negative sign means it's going to go down, because this is the vertical shift, so vertical shift moves up and down 5. Okay, one more example. So once more, I'm going to circle my horizontal shift, and I will box my vertical shift. And if you notice, there's no vertical shift, so I'm just going to go ahead and write no shift here. And for my horizontal, I'm going to set this argument, the argument of the log, equal to 0. And I'm going to solve for x. So I will add 2 to both sides, and I will have x equals 2. So my shift is going to be to the right 2.